So we have a new large language model release in the ring. And this one, it arrived with a very suspicious resume.
Right.
It's GLM 4.7. And the initial reaction across the developer landscape was exactly what this comprehensive review we're looking at describes.
What's that?
That feeling of a too-clean Git history. You know, it just looks a little too impressive.
Yeah, claiming these huge leaps in coding and reasoning tool use. But the question is, what got smoothed over to look this good?
Exactly. And that tension is what's so interesting here.
We're talking about a flagship model making some really serious capability claims.
But paired with an entry price point, that feels, I mean, just $3 a month for their Z.ai coding plan.
Yeah.
That feels designed to immediately disrupt things.
It's meant to undercut the heavy hitters, for sure.
So what we really want to figure out for you, the listener, is pretty simple. We're going to break down this binary versus AI review to understand if this model is a real breakthrough.
Something that will actually show up in your day-to-day workflow.
Right. Will it lead to fewer dead-end agent loops, or are we just looking at another benchmark puff piece that we can all safely ignore?
It has to be useful to you. It needs to be a daily driver, not just a weekend experiment.
Okay, so the key specs, they're clearly aimed at these high-performance agent workflows.
A massive 200K context window, and you can get up to 128K output tokens. But the headline everyone is focused on
Is that score?
that 42.8% on humanities last exam, HLE.
And we had to stress this right away. The review is very clear about it. That score is with tools enabled.
That distinction is so critical.
Because it tells you what kind of test HLE really is. It's not a trivia contest, it's a workflow test.
Exactly. And that $3 entry price, which, by the way, supports agent tools like Klein and Roux Code, that's why the market is paying attention. It shifts the whole conversation.
Okay, so let's unpack this, starting with the skepticism. Because we've all seen enough of these big jump releases.
Yeah.
And the immediate question is always, did the capability genuinely move, or did the evil harness just get friendlier?
And what the analysis suggests is that the interesting story isn't that one heroic number. It's a deeper focus on engineering choices.
Choices aimed at what?
At making agents less fragile. The marketing talks about intelligence, sure, but the core development focus seems to be on stability and control.
Now that's a critical distinction.
Yeah.
Because if you're out there scouting for the best LLM for coding in 2025,
Yeah.
the review says you should watch failure modes, not highlights.
Yeah.
A great model isn't just one that can solve a cool problem once.
It's one that can adapt to messy tool output, stay consistent for hours, and then not lose its mind when you change the requirements mid-task.
Which happens all the time.
All the time. And that focus on robustness, it's right there in the specs. That 200K context length isn't just for bragging rights.
Yeah.
The analysts put it perfectly. It's permission to keep all notes, code, and constraints in one place without playing token Tetris.
I love that phrase. It's so true. It's a practical ceiling, not just a theoretical one. And we can't just slide past the quiet one in the spec sheet.
The open weights release.
With a permissive license. This matters so much for flexibility.
For compliance, for privacy, or just for not being rate limited in the middle of a sprint. It means you can actually move the model to your own infrastructure.
So when you look at the whole capability menu, it's all tuned for agent loops. It has the modern stuff, streaming, function calling, structured outputs.
But the real differentiator seems to be this focus on what they call model plus agent ergonomics. Basically, how smoothly does the model actually help you build stable, multi-step workflows?
This is where it gets really interesting, I think. Let's talk about a core mechanical change. Preserved thinking. This is the feature designed to address what developers call the goldfish problem in agents.
Right, the goldfish problem, where the agent does something complex, maybe calls a tool, and then it sort of rederives its whole plan from scratch.
Forgetting its own reasoning from the last turn.
Yeah, and that inconsistency creates drift. And drift is the fastest way to derail any long agent workflow.
So how does preserved thinking actually fight that drift?
It explicitly retains the internal reasoning blocks across turns. It just carries that crucial context forward.
So the agent isn't starting its internal monologue from zero every single time.
Exactly. It's really a stability feature that's just dressed up as a reasoning feature.
Yeah.
It mirrors how a real human coding session actually unfolds continuously.
And there's a companion feature, interleaved thinking.
Right. Which lets the model think before it responds or calls a tool. But what's really clever, I think, is the turn level control.
Oh, you can turn it off.
You can. You can disable the deep reasoning when all you need is like simple formatting or a quick answer. You don't need a philosophical treatise on the problem every single time.
That's not just about speed, that's a cost-saving measure.
A huge one.
Yeah.
Which we'll definitely circle back to.
So if we connect this to the bigger picture, where does GLM 4.7 really stack up against, say, Claude or GPT? The review positions it right against Claude 4.5 Sonnet.
In that agent coder lane, yeah.
So what are the outcomes we should actually queue about?
The analysts say it comes down to three things: fixing real bugs, surviving those long agent loops, and generating shippable UI.
And that third point brings us to what the review calls, delightfully, vibe coding.
Hey.
You say, okay, that sounds like a meme. Is this actually a useful, quantifiable metric, or is it just marketing fluff?
Well, for front-end development, it matters a lot because UI is so pass-fail, you know.
Either it looks right or it doesn't.
Exactly. If the model spits out a web page or a slide layout or a component that's clean enough to actually keep that saves you hours of manual work, the claims here are for a big jump in front-end aesthetics. Cleaner pages, better layouts, accurate sizing.
So the vibe actually has a monetary value.
It does.
Let me see if I got the personas right from the review. It says Claude often feels like a careful senior engineer.
It's thoughtful. Yeah.
GPT 5.2 feels more like a fast generalist.
It's quick. It knows a lot about everything.
And GLM 4.7 with this whole preserved thinking thing is aiming to feel like a persistent agent teammate that keeps state.
That statefulness. That is the key competitive advantage you'll notice. And it's not a day one speed metric. It's a day two reliability metric.
Especially in those long, complex tasks.
Mm-hmm.
Okay, let's talk numbers again. Specifically, humanities last exam, that headline score, 42.8% in the tool-enabled setting. What is the real implication of that specific test?
Well, HLE is designed as a workflow test. The real story is the difference between the tool-enabled score and the non-tool score. The tool use provided a massive lift, and that's because the model has to decide when to call tools, how to format those calls correctly, and then how to integrate the results without losing the plot.
In other words, tool use isn't cheating.
It's the job.
It is the job of a modern agent. And if GLM 4.7 is genuinely better at that, as the benchmarks suggest, the payoff shows up when you build complex agent frameworks on top of it.
Absolutely. Now, on the pricing reality, that $3 plan is a really cheap wrapper for these AI-powered coding workflows.
But if you're integrating directly,
the API costs are 60 cents per million input tokens and $2.20 per million output tokens.
Okay, but let's circle back to what the review called the second-order cost people miss.
The verbosity.
Right. Output tokens are the expensive ones, and if your model just rambles on, those costs can spike really fast.
And that's where those control mechanisms we talked about become a crucial cost-saving feature. The ability to tell the model when to think hard versus when to just give a concise answer. An efficient model is a cheap model.
So what does all this mean for privacy? Let's talk about control.
Right.
Hosted platforms enforce their policies. Local models enforce yours.
And for private repositories or regulated data, running the open weights model locally is really the only way you can ensure you control the logging and the data flow completely.
But for those who do prefer the hosted API route, the review offers some reassurance.
It does. It mentions that Z.ai's API data processing addendum states the company doesn't store content that's provided or generated through the API calls. It's all processed in real time.
So that's a pretty clean compromise for a lot of teams who need scale but don't want their proprietary data retained.
Yeah.
Let's switch gears for a second. Coding is the main event here, but what about non-coding use cases?
Yeah.
Can this stability help with, say, creative writing?
It's a great question. Communities like Our Silly Tavern AI, they're always looking for character consistency, deep lore tracking.
Like making sure a character knows all the nuances of RWBY lore across hundreds of turns.
Exactly. And the reported vibe is positive. Less slop, better character continuity. Those are direct benefits of something like preserved thinking.
Any tips for using it for that?
The review suggests, starting with the recommended defaults, a temperature of 1.0 and a top of 0.95, that should keep the writing lively without it getting chaotic.
Okay, last thing on this.
Oh.
If you do opt for local control, what's the hardware reality? because open weights is great, but it usually needs some serious muscle.
Oh yeah, you need to plan for some high-end configurations. We're talking an M3 Ultra on a Mac or serious multi-GPU setups.
Like dual 3090s or 4090s.
At least for the 4-bit quantizations on TCs if you want good latency. The good news, though, is that migrating from 4.6 to 4.7 is refreshingly boring.
That's what you want here.
You just update the model identifier, mostly.
Okay, any key details to remember if you are migrating?
2 things. The default sampling is temp 1.0 and top 0.95. And if you're handling tool use, you have to enable toolstream true to get the arguments as they're being formed.
Got it.
So to kind of synthesize the final thought here, GLM 4.7's unique selling point isn't really raw intelligence.
No.
It's its ability to maintain state and context across these complex, multi-turn agentic tasks. It really challenges the whole assumption that stability has to come at a premium price.
So let's quickly summarize the verdict from the review. The pros seem to be the cheap entry, the strong tool use, preserved thinking for stability, and of course, the open weights option.
And the cons are that local runs demand a ton of VRAM, and you have to be aggressive about controlling verbosity or you'll pay for it in output tokens.
So the final verdict is pretty simple then.
It is. GLM 4.7 is engineered to stay on task inside an agent. It's for developers, for product builders, and for privacy maximalists. The advice is to test it on a real repository this week.
And make it earn its keep.
Exactly. The core message is, if it saves you time and keeps you confident enough to ship, that's the only benchmark that really matters.
So given this clear move we're seeing toward optimizing LLMs for stability, not just for peak intelligence scores, here's something to think about. Which of your most complex, frustrating, unfinished tasks, the ones that require absolute consistency over hours or dozens of turns, could this new focus on preserved thinking and statefulness finally solve?